Hello and welcome to Wheel of Fortune. Let's meet our guests for today's game. First we have Sydney Mann. Tell us about yourself.
Good evening. I'm Sydney Mann. I studied at Oxford University on the wrapping function. Spinning-wise, I should do very well this evening because of my studies.
The wrapping function. Care to explain?
Yes, the wrapping function. Come closer and I'll explain. First, you must be educated on the unit circle. That is a circle that has a radius of 1. Here we are. I'm sorry, it is not very perfect. Now let's say there's a point that is 30 degrees, which is also pi over 6. You can go around the circle 1 time, and that would be exactly 2 pi radians. And that would make it equal 2 1/6 pi, which would also equal 4 1/6 pi, which would also equal 6 1/6 pi, and on and on and on. It goes on forever. Also, it works negative just the same. You can get to that point with negative 11 pi over 6, which also equals negative 211 pi over 6, or negative 411 pi over 6, and so on and on and on. Now we will explain the different points on the unit circle. So we already told you about pi over 6. There's also pi over 4, pi over 3. This line is pi over 2. And that is all in the first quadrant. I will explain cosine and sine for each of these. For pi over 3, cosine is 1/2 and sine is root 3 over 2. For pi over 4, cosine is root 2 over 2 and sine is root 2 over 2. For pi over 6, cosine is root 3 over 2 and sine is 1/2. Now, also, this line is at 0. At 0, cosine is 1 and sine is 0, which also makes sense because if this were a quadrant plane, it would be over 1 up 0, which is what the points are. At pi over 2, cosine is 0 and sine is 1. These are all very important because when you go around the unit circle using the wrapping function, each sine and cosine remains the same. So like I said, for pi over 6, how it could be also 2 1/6 pi, that would also have the same cosine and sine. Now, in quadrants 2, there are also these coordinates. This is 3 pi over 4. This one is 2 pi over 3. And this one is 5 pi over 6. Now, these cosine and sine values are very similar, but they are negative. So for this one, sine or cosine would be negative 1/2, but sine would still be root 3 over 2. For 3 pi over 4, cosine is negative root 2 over 2, and sine remains root 2 over 2. Now, for 5 pi over 6, cosine is negative root 3 over 2, and sine is 1/2. The reason cosine becomes negative and sine remains positive is because cosine moves left and right on the coordinate plane, and sine moves up and down. So, in coordinate 2, the cosine has to move backwards, so it must be negative, but sine still moves up. And the reason that they are the same as across is because they make the same triangles, as you will see here. There's a triangle here, there's a triangle here, there's a triangle here, and it goes across like that. This value is pi, and the sine and cosine for that is -1 and 0. Now, we will go into coordinate 3. In coordinate 3, sine and cosine are both negative because it goes back and down. The values in quadrant 3 are 7 pi over 6, 5 pi over 4, and 4 pi over 3. And like I said, cosine and sine are both negative and they make the same triangles, which is very, very convenient. Now, in quadrant 4, sine is negative and cosine is positive because cosine is moving forward again to get to these points, and sine is still moving downwards. This line is 3 pi over 2. The sine and cosine are 0, -1, because as I said, sine is negative. This one is 5 pi over 3. This one is 7 pi over 4. And this one is 11 pi over 6. Now, that is the entire unit circle. Also, this one ends at being 12 pi over 6, which also equals 2 pi. Now, using the wrapping function, you can keep going around and around, and you can also go around negative.
Oh, thank you for the useless knowledge that we'll never use. And now, to meet our special guest, Asia Mann. Tell us about yourself, Asia. Thanks, Asia. Now the category is common phrases in math class. Okay, Sydney, why don't you spin first?
Alright, I just need to grab out my handy dandy string out of my pocket. Now let's measure this out. Alrighty, so let's pull this around, and out of all the categories, I want to go on the trip to Hawaii, so I need to spin 7 pi over 6, looks like, which also means I could spin 2 7 pi over 6, 4 7 pi over 6, 6 7 pi over 6, or any of those values on and on, adding 2 pi. Yep, I want to go to Hawaii. I accidentally spun 5 pi over 6 instead of 7 pi over 6. No! My studies have failed me! If only I paid attention to my math teacher junior year.
And Asia wins!